Here are the answers and the work solutions for the do now, number 1 and 2. Remember those intervals, those brackets are not the same as parentheses, sorry. They are not the same as parentheses. The brackets show that it's x and x. x1, x2, x1, x2. As I was telling Jahira, you need to make sure that you're substituting in both of those numbers to get your two y's. And when you do that, you have your y1 and y2. Then you take that and substitute it into your slope formula. Oh, I thought you. Questions on number 1 or 2? Snaps or hands? Oh, thanks. Hands if you have a question raised, not applause, sir. Thanks, though. I appreciate it. If you don't have it down, go ahead and take a minute to write it down. Okay, Giselle, I'm going to post the video. Just watch it. Can I go? Or some of us still writing? No, I still see people writing. I'm not going to go yet. Definitely too close together. Ready now? Yes, no, maybe so? All right, nobody's saying anything. 3 and 4, you don't have to find the y value because they're on the graph. They're already on the graph. You don't have to do any additional math. They're on the graph. Are there any questions on numbers 3 or 4? All right, when you're done typing that down, flip it over. We're going to work on level 2 examples today. Level 2 examples today. Level 2 has to do, gentlemen, yes. Level 2, 3, and 4 will deal with word problems. Okay. All right. We are getting started. Okay. That's fine. I told him he can do that. Okay. Level 2, 3, and 4, the only thing that changes is word problems. We're still using the rate of change formula. We're still using the change of y over the change of x, which is, as you did in the do now, y2 minus y1 over x2 minus x1. However, for word problems, you have to make sure that you're showing work. If you are not showing work, you're not going to get full credit. If you're not showing work, you're not going to get full credit. The other thing that you need to do is include units. If you do not include units, you will not get full credit even if your work is correct. Because I don't know if you're talking about apples, oranges, Doritos, Flamin' Hots. I need to know what the problem is or what the answer is in context of the problem. It's the only thing that's different. is that you need to make sure you're showing all of your work. No? Okay, then you don't get full credit. And including your units. Okay? All right, so let's look at number 1, example 1. You're going to have 3 types of problems: a graphing problem, a function problem, and a table problem. Just like in level 1, you had a function. He asked if you loved him. Would you like to be embarrassed more, sir?
I don't think it was that.
Okay. Can I continue? You're going to have a graph problem, a function problem, and a table problem. Just like you had in the do now and level 1. You have a graph problem and a function problem. Now we have a table. Okay? You have to make sure you're reading the problem to understand the context and what you have and what you don't. Okay? When you're going to do your practice today, I'm not going to answer questions unless you ask me something specific. If you ask me how do I do this, I'm like, oh, what kind of problem is it? Function. Great. Go to the function problem in your examples and try it. Okay? Tiffany? Okay. Make sure you answer him while you're walking over there. Okay. Let's look at the first problem. The first problem says below is a graph. So there is one type of problem, graph, of the temperature of an object flying to the sun to measure temperature. Find the average rate of change between the 1st and 5th hours. Include units. Okay? What do we need to find? Not units, not just units. What else do we need to find? Average rate of change. Thank you. I think that was Emilio. Okay. But average rate of change between what? First and 5th hour. 1st and 5th hour. Miss Santana, how do I know what's X, what's Y? Easy. They give you a graph. Which unit? You don't have the right paper? This is on the do now. Flip it over. Okay. Are you good now? How do I know my units for X, and how do I know, Rafa? How do I know my units for X, Rafael?
By looking at the X and looking up.
Looking at the X and looking up.
Yeah,
I don't understand what that means.
Where the line is, like.
How do I know what my units are for X?
Your unit is the left.
Mm-hmm.
The one left.
No.
Get it? The one?
No.
That's X.
That's not units.
X is time.
In this case, yes, X is time. Why? Yeah, what is this called?
X-axis.
This is the X-axis, so this is going to be my X units. Elvis, what are going to be my Y units?
What's going to be the temperature?
In what?
In Fahrenheit.
How do I know that?
Because it says temperature and then in parentheses there's F.
But why is it temperature?
Because it says it.
It's the Y-axis. Thank you, Alicia. So this is my Y units. Temperature and hours. Degrees Fahrenheit and hours. Question. Okay. So we have 1st and 5th hours. 1st and 5th hours. What variable is that? What coordinate? X. Who said that? I don't know who said that. Why is it X? Because it's time. Time is in hours. So this is going to be X, and this is going to be X. Oops, that's supposed to be 2. So X1 is what, and X2 is what? 1 and what? And 5. Emerson, why is it 5? 5th is 5. How can I find my Y's? It's on the graph. Check the graph. We have 1 and what? And 5 and what? 1640. Questions? Gentlemen, we're being too goofy right now. Okay, so now we need the change of y over the change of x. But before I do that, in order to make sure you have your units, this is what I do. You can do whatever you like, but just make sure you include the units. My y units, we already said, are degrees Fahrenheit. My x units is hours. Okay, so I know that I'm going to need to include this in my final answer. So I'm going to do the change of y. Oops, I don't need that parentheses, my bad. So I have 1,640 minus 700 over 5 minus 1. And when I put that into the calculator, I get 235. What'd you say? Yeah. You might not always have a whole number though. Okay? And that's okay. Alright? But let me point something out. So remember in level 1, I wanted you to put it into a fraction in lowest terms. For word problems, you need a decimal. Okay? Because we do everything with whole numbers and decimals. Okay? Word problems, make sure they're decimals. Yeah, I'll tell you what to round to. I don't know who asked that. Was that you? Yeah. I'll tell you what to round to. Questions? Is that your final answer? No. What are we missing? Units. And that is degrees Fahrenheit per hour. Okay? So you can write it like that, or you can write it in a sentence or phrase, 235 degree Fahrenheit per hour. Okay? Questions? All right. Since there are no questions, let's do checks for understanding. How do I know what my units are for a graph? The x and y axis tell you the units. How do I find my y coordinates for my graphs? Look at the graph. What specifically? The y value for the x. I think that's good. Questions? Are we sure? We sure? We're sure. Okay. Can I go down? Everybody have that? All right. Let's look at number 2. Rafa, you going to? Oh, he went. An astronaut drops a rock off the edge of a cliff on the moon. The distance d of t in meters the rock travels after t seconds can be modeled by the function d of t equals 0.8 t squared. What is the average speed in meters per second of the rock between 5 and 10 seconds after it was dropped? All right, they give us a number of things here. What is one thing they give us? D of t is what? Distance in meters. Very good. What else do they give us? T seconds. What else do they give us? The function. What else do they give us? 5 and 10 seconds. They give us one other thing that is really important. In what? Meters per second. So here, you don't have to guess what your units are. You don't have to guess what your units are because they tell you. They tell you in 2 different spots. They tell you d of t is in meters and t is in seconds. This is function notation. Remember, function notation is f of x, right? Inside is your x value and f of x is y. If you don't have this right here, keep this in mind. Inside is x, the whole thing is y. So in this case, d of t, which one is x? T. And which one is y? D of t. Okay? And then lastly, it tells me meters per second. How do I know, or what is my y units and what are my x units in this? It's okay if we don't know. Meters not x. Remember, it's the change of y over the change of x, right? And this word per implies that it is a fraction. That's a fraction. So it's going to be meters per second. Okay? This is y per x. Y divided by x. Got it? Okay? Are we sure? So if they give you the rate in words, the one before the per is x, y, the one after is x. Y, x. Questions? Questions? Are we sure? Okay. So we have 5 something and 10 something. How do I find those somethings? Substitute. Plug them in. Plug them in for what? The t. Very good. So my y1 is going to be 0.8 5 squared. And when you put that into the calculator, you get 20. Y2 is 0.8 times 10 squared. And when you put that into the calculator, you get 80. Questions? Am I going too fast? Do we understand where I'm getting these numbers? Do we understand what I'm substituting them into? Okay. Am I done? What do we need to do? Very good. We need to do the rate of change. Y2 minus Y1 over X2 minus X1. So 80 minus 20 over 10 minus 5. I got 12. 12 what? Meters per second. Or in words, 12 meters per second. Who is that? Oh, that was you, Christian? Rafa, you going? After you come back. Questions. Are we sure? All right, last one. Christian, can you see that? Okay. On a road trip, after picking up your friend who lives 10 miles away, you decide to record your distance from home over time. Find your average speed over the first 6 hours. What do we got here? 10 miles away? So that coincides with what? To 0. That goes with this. You have not traveled since you got there. 0 miles, 0 hours away. What else do we got? Say that again. Distance from home over time. Where did I say that? Okay, here we go. What else do we got? 6 hours. So what does that coincide with? 292. Questions? Okay. Now we need to figure out what my x units are and what my y units are. There is something that I underlined here that tells me already what my rate is. Distance over time. Okay, so distance over time. What is distance measured in? Miles. What is time measured in? Hours. Okay? What if they didn't give us that? There's one thing in this table that tells me what's y automatically. Very good. This d of t, this function notation, tells me this is y, because this is like f of x. Good job, Tiffany. Okay, questions so far? All right, so now that I have the two things, how can I create my coordinates to find my rate? Coordinates. What is a coordinate? What's it composed of? An x and y. Very good. So what is my x and what is my y for my first one? 0. And then what? 10. Is that you, Alicia? Thank you so much. Are we sure we understand this? Because I only hear like 2 or 3 people answering. Are we sure? So when I walk around during practice, everybody's going to be doing the problems correctly. Are we done? No. So what do I got to do? Elvis, what do I got to do? Yes. So we have 292 minus 10 over 6 minus 0. And that gives me 47. 47 what? Miles per hour. Or you can do 47 mph because that's what we know in the US. Or you can do 47 miles per hour. And make sure you put the MI because M stands for meters. MI is miles. Questions, comments, concerns, compliments. What'd you say? Thanks. Questions. All right. Then I passed out today's practice sheet. I want you to flip to the back that has the word problems. Did I not give you guys any? Okay, I'll give them to you in a second. I always forget one group.